Hi guys, this is a video tutorial on dividing polynomials. Okay, so what we're doing when we're dividing polynomials is we're getting a partial factorization. So in the last chapter we talked about expanding brackets and sometimes multiple brackets to give varying degrees of polynomials. So as with the quadratics, we're doing the opposite to expanding, so we're factorizing. Okay, so in this, what we do to use, we use the long division algorithm, okay, to divide polynomials. Now, what I mean by that is the algorithm is a series of steps that we perform to achieve a task. It doesn't just, you might have heard about it in regards to computers and programming, but it just applies to anything. So it's just a series of steps. I've got this example over here. Just if you can't remember how to do the long division algorithm. So we look at, over here we've got 7 into 4, won't go, so what we do is we look at 7 into 40. Now we know that 7 into 40, well, 7 times 5 is 35, so we put the 5 up here. And what we do now is we times that by that, 7 by 5, and we get 35. Okay, we put and we subtract the two the two values here. 40 minus 35 is 5, and then we bring down the next value. Okay, so we do it at 2 at a time because we can deal with 2 digits a lot easier than we can deal with 3 or 4. Okay, so again, I'm looking at 55 divided by 7. I know that 7 times 7 is 49, so that will be 7 times 7 is 49, okay? And then again I do my subtraction, so 55 minus 49 is 6. Okay, lastly I've got my 0, which I bring down, so 60. So my last value is going to be 60 divided by 7. 7 times 8 is 56, okay? So I take away and I get, okay, in this case, 578, sorry, oops, I crashed it, oops, I might have to delete that one. Okay, so in this case I have 4070 divided by 7 is equal to 578 remainder 4. Okay, so we're going to get something very similar to this when we come to divide polynomials. Okay, so we use the same algorithm. It's a little bit more complex because we've got variables. I'll just move that over here out of the way so we don't confuse things. So here's an example of one we might do for a polynomial. So divide p of x. P of x is a cubic, x squared, x cubed plus 2x squared minus x plus 3 by x minus 2. Okay, so the aim of this is to factorize a cubic. So instead of expanding it, we're factorizing, we're going the other way. And the reason why we might do this is to find solutions to x, just like we did in our quadratics. Okay, so just a few things here to note, some naming conventions. This is called the divisor. Okay, so I'll just get a different color pen. This is called the divisor. This bit here, that's that bit there. This bit is called the dividend. All right, that's that bit that we're dividing. Oops, that's not very nice. Now the result, which is going to come up on the top here, just like in the one we did before, is going to be called the quotient. Oops, quotient. Okay, which is the result of a division problem. And at the end, right at the bottom, we may or may not get a remainder. Okay, so at the end, we might get a remainder if the divisor is a factor of the quotient. And we'll talk about that in a further class. You won't get any remainder. Okay, so there's some words that you need to know: divisor, quotient, dividend, and remainder. Okay, so in this example, we've got a cubic divided by a linear, so x cubed here, and we're going to divide it by this. So what we do is as with the number problem, we're going to look at the first 2 terms here first. Okay, so I'll just get rid of that actually. So first of all, we look at this term here, and we're going to divide it by the first term in the divisor. Okay, so x cubed divided by x is equal to x squared. So that's what goes in our quotient at the top. Okay, so this times this is going to equal this here. Alright, so that's the first step. Okay, now what we do is we're going to multiply this out. So as we know, this times this is x cubed. Now this times this, okay, goes in the next spot here. Okay, so x squared times negative 2 is negative 2x squared. Okay, so I'm always working with my two terms because there's two terms in my divisor. Alright, so as with the number problem, we put a subtraction line, and what we're doing is we're taking away. Okay, so in this case we're not working with numbers, we're working with algebraic terms, so polynomials. Now what you'll find is the first term will always cancel out. Okay, so x cubed minus x3 should always equal 0. Okay, and that's the way we're going to repeat this algorithm until we've got nothing left in our dividend. Okay, so that's how this works, and we're always going to be working to get rid of the first term. Okay, until we get to the end. So now negative 2x here, sorry, 2x squared, take away negative 2x. Now if we take away a negative number, we add it. Okay, so in fact we're adding 2x to 2x, which will give us 4x squared. Okay, so that's my new, that becomes my new dividend. Alright, now I've only got one term now, so I bring this next term down. Okay, so I've got negative x. Okay, so I'm no longer working with this dividend here. I've actually got a new one down here, and we're working back with this. Actually, I'll just stop for a second. Okay, so I've just erased all the highlights that are unimportant. But now instead of working with this top red line, we're working with this here. Okay, so we've got two terms, and we've got the two terms here. Okay, so again, we're looking to create a quotient term. So we divide 4x squared by 4x squared divided by x to get this value here. So 4x squared divided by x is 4x. Okay, so imagine 4x times x is 4x squared. Okay, and that's in fact what we put in our next line. So 4x squared, okay, that will give us our, that will eliminate that first term. But we now have to work on the second term. Okay, so we're not working with this anymore, we're working with the next one. Alright, so 4x times x squared, we've already got that here. And then 4x times negative 2 is going to be negative 8x. Okay, so let's now do our takeaway. So I put my line down here, and I'm going to take away this to eliminate the first variable. Okay, 4x squared, take away 4x squared is 0. Now, negative x minus 8 is in fact a plus 8. Okay, so if we think about negative 1x plus 9x's, what do we get? Sorry, plus 8x's, and we should get 7x. Okay, so that's our new quotient. Okay, so now we've only got one term because our 0 is gone. Our 0, we've eliminated that one there. We bring down our plus 3, and in fact that's the last one we can bring down. So the quotient up there is going to be a quadratic. Okay, I'm going to just stop it. Okay, so we've now got our two terms here, and we're looking at the first term. Okay, so 7x divided by x is going to be positive 7. So that is my the end of my quotient. Okay, And as before, we now multiply this by 7 here to get our subtraction. So 7x, and then 7 times -2 will give us -14. Okay, so I'm just going to delete those so we're not confused. All right, we did the same thing again. This is the last time we do it. It looks like we're going to end up with a remainder here. Okay, so finally, my final step is to take these away. And obviously, again, 7x is designed to eliminate that first term, so that becomes 0. Now, positive 3, take away -14, so plus 14 is 17. Okay, so I'm just going to erase that 0 because that's just confusing. And this is called a remainder. Okay, so in this question, we'll talk about this a bit later on, but this is called a remainder. Oops. All right, so what that means is that this divisor is not a factor of this quadratic cubic. All right, so the way you write this, okay, this can be expressed like this. P of x can be expressed as the product of the quotient, okay, times the divisor plus a remainder. Okay, so 17. Okay, so we've got partially factorized cubic. All right, so that includes this, the divisor, and a remainder. Okay, so that's how you use the long division algorithm to factorize a cubic.